Alright, so for problem 98, it says Jack, little dude up here, is on a Ferris wheel. That's the Ferris wheel. It's quite Ferris wheel. And it's rotating a constant 0.1 revolutions per second. So it's rotating 0.1 revolutions per second. As he passes through the highest point of his circular path, which is up at the top, the force that the chair exerts on him, so the force the chair exerts on him is equal to 1/4 the force of his weight. And then it asks you, what is the radius of the circle at which Jack travels? And it says to also treat him as a point weight, which makes it just a little simpler, that's all. So, the first thing to do here is to figure out what exactly this means here. So this means that the force that the Ferris wheel is exerting on him is equal to 1/4 times his mass times gravity. We don't know his mass, but we do know gravity, so that's kind of almost good. We also know that, so we're going to use tension to solve this one because that has all the things that we need, and that's pretty common with these things. So his tension, or the tension of the Ferris wheel, is equal to mass times velocity squared over the radius. So if we set that up, we get that since we already did this here, that the tension equals 1/4 mass times gravity, because tension is the force that's pulling him or pushing him up and like keeping him from falling. It's just a negative tension at this point, but anyway, it doesn't matter. So 1/4 times mass times gravity equals mass times velocity squared over r. So the next thing to do is to figure out what v is. Or actually, the first thing is you can cancel out all the masses. So it's just 1/4 times gravity equals velocity squared over r. At that point, we know everything but r and v, and we need v to solve for r. So v is equal to the rotation. So right now it's in revolutions per second, and we want that to be in something we can use a little easier, like radians per second. So one full circle is 2 pi, so that's one revolution is equal to 2 pi, and then this, it would be one revolution every 10 seconds since it's 0.1 revolutions per second. So if you multiply it all by 10, it's 1 revolution per 10 seconds. So you get that it's 2 pi over 10 radians per second, or 0.2 pi radians. So then you can come back and plug that in here, or actually over here, because that's his rotational velocity, or omega, and velocity equals omega times r. And since omega equals 0.2 pi, we get that the velocity equals 0.2 pi r. So you can bring that back over here and get 1/4 g equals 0.2 pi r, all that squared over r. And then this, when you square it, the 0.2 turns into a 0.04, the pi turns into pi squared, the r turns into r squared, which we can then use one of those r's to cancel out the r on the bottom. So you get 1/4 g equals 0.04 pi r, or pi squared r. And then you can bring everything over to one side except for the r, so you just divide the 1.6, or the 1/4 g times all of that. I did this kind of weird, so I had brought all this over and then multiplied the bottom by 4 to take care of the 1/4, so you get 9.81 over 0.16 pi squared equals r, and then that comes out to be 6.1 or 6.21 meters.